Hello dear student, this is Devang Shah from LG Institute of Engineering and Technology. We have been learning the subject basic electrical engineering, and so far we learn about the topic which is called a transformer. In that we have discussed the BH curve in our last session. Now in our today's session, let us start with the transformers and their constructions. Then we are going to discuss about the working of transformer and EMF equations, then ideal transformer and practical transformers. Then we will discuss about the three-phase transformers, and lastly we will discuss about the auto transformer, right? So let us start with the transformers and their construction. So first learn about the importance of transformer, where I have to use the transformer, why the transformer is needed in an industrial application, why the transformer is needed in a residential applications, right? So all over you can see the application of transformer, where even you are charging your mobile phone. In that there is a conversion from AC to DC to charge your mobile phone. For this conversion, the first components to convert AC signal to a lower value of AC signal, you require a transformer, right? So you can see here there is a power plant where the AC signal generation is possible. From this there is a 12 kV of AC generation, and that 12 kV is applied to the step up transformer. From that step up transformer, that is converted into a 400 kV, and kV will be transmitted over a long distance, and at the end you can see the step down transformer, and that step down transformer again is going to be converted into a 13 kV line, and from this 13 kV line from the grid, that can be available for a residential or industrial application. So you can see the complete terminology here, where there is a power station. From power station there is a generation of three-phase AC signal or single-phase AC signal. From make it a step-up transformer. So you have to design a step-up transformer. So that particular line, the generation of 12 kV is converted into a 400 kV through the step-up transformer, and that is transmitted through a transmission line. And at the receiver side, you can see there is a distribution. So for this distribution, 400 kV is converted again into a 12 kV at the grid, and from this grid it is transmitted over your home or any industrial application. So this is how, where the transformer is needed here. The transformer is needed to step up the voltage, as well as transformer is needed to step down the voltage. Step up the voltage and step down the voltage. Now at simple at your mobile charging, you are using the step down transformer, right? So this is what the about the importance of transformer and the functionality of transformer. Right now we further discuss about the transformer. So what is a transformer? So let's discuss about the definition of transformer, where it requires, or it has a two windings. One is called a primary winding, another one is called a secondary winding. So based on this symbolic representation of transformer, here you can see there is a primary winding, there is a secondary winding, and in between there is a core, and that core is a laminated core. So once you apply the voltage at a primary winding, there is a generation, or there is a production of magnetic flux around the core, and that will generate or induced EMF. So basically the transformer is a static device. It is not a movable device, but transformer is a static device that transfer electric power from one circuit to another circuit with the change in voltage or current level, right? It does so without change of frequency and power, and it accomplishes this by electromagnetic induction, which is called a mutual inductance. So here, as I said, the generation of magnetic flux that will linked with the secondary winding. So this induced EMF we define as a mutual induced EMF. That is called the basic principle behind the transformer. So here the transformer is working on a principle of electromagnetic induction, and this given by Faraday's law. Now let's check the symbol of this transformer. So you can see this is a symbol of transformer, where at one end you have a primary winding and another end you have a secondary winding, and in between there is a two parallel line you consider as a core, right? Now same here, if we talk about this is a core, and it is a rectangular shape that is defined as a core. So at one end you have to wound a specific coil, and that coil we define as a primary winding, which is connected with the source, and that source is a AC sinusoidal source in between with the switch, right? So you consider now the another arm of this rectangular core, you have connected a secondary winding. So always remember, primary winding is connected with the source and secondary winding is connected with the load, right? So here once you apply the AC voltage, then there is a switch. If you going to connect, so there is a primary winding having the number of turns is N1, there is a secondary winding and having the number of turns of N2. This is how here the once you apply the current to the primary winding, so because of the current which is flowing in a primary winding, that will produce a magnetic flux around it, and that magnetic flux is again linked with the secondary winding, right? So again there is a mutually induced EMF in a secondary winding. Because of this phenomena we define as a transformer, right? So this is a very simple terminology where you can see here the current I1 is flowing in a primary winding, and because of this there is a production of magnetic flux around the coil, and that magnetic flux is also linked with the secondary winding which is having a number of turns of N2, and because of this flux is linked with the secondary winding, it will also induce EMF EM in a secondary winding. This is called a mutually induced EMF. Now that's how it will transfer one AC power into another AC power in terms of voltage or current. This is what it calls the working of transformer. Now let us discuss about the construction of transformer, where there are two types of transformer in on the base of construction. Namely, one type of transformer is called a core type of transformer, and another type of transformer is defined as a shell type of transformer. So here once you discuss about the core type of transformer, so in the core type of transformer the windings are placed surrounding a considerable part of a laminated core. So let us discuss what is it. So if you further discuss about the cell type of transformer, so in this type of transformer the laminated core placed surrounding a considerable part of the winding. So let us discuss one by one as a core type of transformer, where in core type transformer there are mainly two parts. One is called the core itself and another one is called the winding. So any transformer is made up of a core and winding, right? So let's discuss about the core. So this is a part of the core where you can see the single lamination staples are used. Those staples are made up of the magnetic materials like iron, steel, right, and which is laminated. This type of strips or staples are connected together and that become a core, right? So here you can see here this staples are in form of L shape. This core is made up of the silicon steel to reduce the hysteresis loss, as well as the types of core is square or laminated to reduce the eddy current loss, where you can see there are two numbers of limbs. So the limbs is nothing but the part of the core on which the winding is wound is known as the limb. So you can see here there are two limbs. Same way here there are two yokes, and the part of core used to join two limbs is known as the yoke. So here is a part of the yoke. Two L-shaped core are interleaving to reduce the reluctance of magnetic path. So here this two L-shaped are joined together and that will make a core. So there are multiple staples are connected together and that will construct the core. Same way now let us discuss about the winding. So this is a part of the core with two limbs and two yokes, where you can see there is a primary winding having the number of turns is N1, there is a secondary winding having the number of turns are N2. So this is a part of the wiring where in any transformer there are two types of wiring. One wiring is called a primary winding and another wiring is defined as a secondary winding, right? So if we further discuss about this shape of this winding is a circular cylindrical coil are used due to the high mechanical strength, where in actual construction the primary winding is low voltage or high voltage, and secondary winding is also available with the low voltage and high voltage, right? So in real case the low voltage winding is easiest to insulate. It is placed near to core, while the high voltage winding wound on a low voltage winding, so the insulation problem is reduced. So you can see this is a core type of transformer where over the two limbs one part is primary winding and another cylindrical shape is the primary winding and another is the secondary winding. With how the low voltage winding and high voltage winding is wound, you can check from this particular figure. Same way in a shell type of transformer, again there are two main parts. One part is the core and another part is the winding. So here you can see this is a kind of core which is having in a E shape or I shape. So here you can see this combination of E shape and I shape. Again this is laminated and there are part of the staples or strips. They are joined all together. So you see the construction of this core in a shell type transformer. So you can see this is the E section and this is the I section, which will be joined together in parts of the limb and yoke. So here the number of magnetic circuits are 2, here double, where the types of material again it's a silicon steel to reduce the hysteresis loss. Type of the core is a rectangular and laminated to reduce the eddy current losses, and number of limbs are here now 3. You can check here. The part of core on which the winding is wound is known as the limb, and only the central limb is winding is wound, right? So here the number of yokes are 2. You can check here, and the core used to join the two limbs is known as the yoke, right? So here the interleaving of E and I core are interleaving to reduce the reluctance of magnetic path. So here you can find this is a core where E and I section which is connected separately in a cardboard form, and this is called a insulating paper, where there is a two windings is going to be wound over this part of the core. You can check here the paper insulation laminated, so the outer part is the core in a shape of E and I, and there is a primary and secondary winding we are going to connect with the middle limb with the leads. So you can check the winding here. There are the winding construction of the shell type transformer, where the on a middle limb we are going to connect the primary winding as well as we are going to connect the secondary winding. So here primary and secondary winding, there are two windings in again in a shell type transformer. So you can check here the multi-layer disc type of also available. Both windings are placed on the central limb, where you can see the 2D way, where in a central limb there is a core part you have connected two windings, primary and secondary, where which is nothing but the alternate layer of low voltage winding and a high voltage winding. Here further discuss about this is the circuit of transformer having the primary winding and secondary winding. These are the different examples of transformers are available in a market that you can directly purchase from the market, right? So now further in a construction of transformer, you can see here in which way you have to construct this transformer. So you can see this particular figure where the middle part inside there is a core and winding, and above there is a tank, right? So you can correlate this particular figure and this particular figure. These are the industrial transformer as well as a residential transformer. See, this part is the core, where having two windings, let us say primary and secondary winding. So this part is available inside. So this particular involved with the transformer tank. So here the complete transformer tank is available here, right? And there is a circulation of the oil in this transformer tank. So you can see there is a conservator tank that is comprises of the oil that is nothing a part of the coolant system, and that will cool down the heat which is dissipated by the operation of this transformer. So you can see this particular where there is a this extended pipes are available, and this extended pipes will continuously will circulate the coolant oil in this particular tank, and that will cool down the operation of this core and transformer. So you can see that the complete mechanism where this particular conservator from here the hottest oil will be going from this way, from this Buchol relay and coming here. Now this will cool it down the oil by this breather circuit. Now this breather is exposed with the air, so that will absorb the environmental air inside this tank, and that will cool it down the oil, and this continuously oil will circulating in this. The extra heat generation dissipation will be provided by this kind of mechanism, where these two windings are coming out of this tank. You can see these are the terminals, and those terminals are a primary winding and secondary windings. Here Buchol relays are specific that will control the in and out of the oil from transformer tank to the conservator tank, right? So this is the complete construction of a big transformer that has a capacity to dissipate more heat, that is capacity to generate more heat during the transformer action. So this is what the construction of transformer. Dear students, thank you very much. If you have any doubt, please write in the comment box.